Welcome back. We are going to finish our 3.7 notes today, which is graphing absolute value functions, and we are at the third page, halfway down this box that talks about vertex form and absolute values. Vertex forms of an absolute value function. So, reading here, it says an absolute value function written in the form g of x equals a times the absolute value of x minus h plus k, where a is not 0, is what we call vertex form. The vertex of the graph is the point h, comma, k. First thing you might notice is the h here is positive, and then inside it looks negative. So you might want to make a little bit of a note that we are going to look at the opposite of what's there. So for example, if I had x minus 3 plus 4, the vertex in this situation would be 3 comma 4 because it's the opposite. All right, keep reading. Any absolute value function can be written in vertex form, and its graph is symmetric about the line x equals h. So if you go, h is the x value, and so x equals h is a vertical line. If you have that vertical line, if you have a point that's 3 spots away from that vertical line that goes through the vertex, then you're 3 spots away on the left. So anyways, let's get into what these individual values mean. First, a negative a value is what we call a reflection over the x-axis. Okay, so sometimes we would say that this is the normal absolute value. This is opening up like a cup. A reflection then makes it open down like a frown. It doesn't look much like a frown when it's a V shape, but that's what we'll say, down like a frown. So that's what a negative does. It's the only thing a negative does. The only thing when you see a negative is it reflects it to open downward. Now, when you look at the a value, if you take its absolute value and it's greater than 1, that's what we're going to call, the graph will show what we call a vertical stretch. Okay? And in a way, it's going to look more narrow or skinny. When the absolute value of a is between 0 and 1, which means it's basically like a fraction or a decimal, not a fraction like 3/2, but like 1/2 or 3/4, the graph shows a vertical shrink. A vertical shrink will look more wide or fat. I know someone's probably going to get offended that I said fat and skinny in a math video, but I'm just talking about what's going on there. Okay. So that's what the a value does. The a value tells us if it opens up or down, is it narrow or wide, which is called a vertical stretch or vertical shrink if we want to get to the technical terms, which we will use. The h value, that's what's inside of the absolute value symbol. So when the h value is positive, the graph shows a horizontal shift to the right. Now, when I say positive, the example here would be like an x minus 3, because the 3 itself is positive, because think about it, we were supposed to have an x minus h. So the 3 is positive because that minus sign is still there. Now, another way you can think of this is think opposite. So if you see x minus 3, you need to think positive 3. You're going to learn anything in the inside of an absolute value symbol is the opposite. All right, so if that's it's positive. If the h value is negative, I'll give you an example what that looks like. That is like an x plus 5. What happens is that's because we had an x minus a negative 5. Okay, and two negatives make a plus sign right there. So my whole value here is a negative. That will show a horizontal shift to the left. Again, if you think opposite, think opposite. So if you see x minus 5, think, oh, sorry, x minus 5, that was the top one. If you see an x plus 5, I'm just going to change that to a plus. You need to think negative 5. Negative meaning going to the left. So that's in the inside of the absolute value symbols. Then we have the k value, the stuff on the outside of the absolute value. So when k is positive, the graph shows now a vertical shift up, and when it's negative, it shows a vertical shift down. Now that's a lot. But, yeah, it's just a lot. But that's okay, because we'll get there with a lot of trial and error and practice. But there's the meat of what we're doing today. So we want to identify those things and then do the graphs of these functions based on what we are seeing happen. So let's go to the next page here. Next page, there we go. Okay, let's look at example 3. Graph h of x equals the absolute value of x plus 2 minus 3, and compare the graph of h to the graph of the parent function. First off, let's do what we did yesterday and graph our parent function. So graph our parent function. So I'm getting that graphed here. So we're going to start with that parent function. I'm going to connect these dots. So there's my parent function. Now, x plus 2 minus 3. Let's start with the plus 2 here. The x plus 2. What does this mean? Go back to the notes. The plus 2 means we are going to the left. We have a horizontal shift left 2. Think about order of operations. What happens in the inside of the parentheses happens first. So we have to do order of operations here. Maybe put that little note here. Order of operations for our movements here. So left 2. So every point I'm going to go left 2. So if I look at the vertex and I go left 2, I'm going to end up at 2, 0. So I'm going to go left 2. And the next point I see, I'm going to go left 2, left 2, left 2. And I'm going to keep doing those. Left 2 from all the points on the right. So here is the first movement. I went left 2. Now, look at the minus 3. The minus 3 meant we had a vertical shift down 3. So all those new points we just did, we're going to go down 3. So 1, 2, 3. 1, 2, 3. 1, 2, 3. And I'm going to keep doing some of those. And then I'm going to do some on the other side. So my final graph is this one right here. Going to use my handy dandy ruler here and connect these right there. So my final graph is this one that I'm doing in red. So how it compares to the parent function, we had a horizontal shift left 2, then a vertical shift down 3, and then our graph is actually that red one. Now if you need to, you use a pencil, and then you can eventually erase those in-between ones. Voila, there you go. All right, I want you to try the on your own and then come back and I will show you what the graph should look like and what you should have for your comparison. So 3, 2, 1, and go. All right, so you can see from my screen here that the x minus 1 was a horizontal shift to the right 1, and then we had the graph that corresponds to that. So you can see the graph compared to my parent function. Okay, I want you to now go ahead and pause the video and do on your own number 6, and then come back and I will show you my graph and I will explain the transformation. So 3, 2, 1, go. Welcome back. As you can see from my screen, the x plus 2 in the absolute value symbols corresponds to a horizontal shift to the left 2, and the plus 2 on the outside is then a vertical shift up 2. Sorry, that doesn't really look like a 2. And you can see from my green graph the final graph of c of x. Okay, let's go to example 4. Example 4 here, again, I'm going to zoom in here. Let's first, we're going to describe the transformations from the graph, and we're going to also do the graph. So let's first make our parent function. So I'm going to start with 0, 0, 1, 1, 2, 2, 3, 3, and I'm going to just do a couple points. Pull out my handy dandy ruler, and let's try to make this pretty smooth. Again, I'm going to do the same thing on the left side. I have some points made, and so there is my parent function. Now let's look at the transformations that are going on. Order of operations says first, remember we are doing order of operations. Order of operations. Order of operations says inside the parentheses first, which is going to be the plus 1. So the x plus 1 is where you're going to go to a horizontal shift to the left 1. So I'm going to put everything to the left 1. Okay, so there's my little template there. Now I'm going to pick a different color. And then I have that negative. The negative is a reflection. A reflection over the x-axis. So what that means is I'm going to start with my vertex. My vertex is already on the x-axis, so it's going to stay there. It's going to stay here. But what you'll notice is I'm going to have to count now. If I'm doing a reflection, let's look at this first point to the right of my vertex, the point at 0, 1. If I'm one space away from the x-axis above it, my new point has to be one space below it. And then remember we talked about that symmetry earlier? If I have a pretend line of symmetry that goes through the vertex, if I'm one spot to the right, my symmetric point is one spot to the left. And then my next point over here is 2 spaces away from the x-axis. I'm going to go 2 spaces away on the bottom. And then I'm going to find its symmetric partner. So if I'm 2 spaces on the right, I'm 2 spaces on the left. And then I can continue that pattern that I see for a few more points. So here is the reflection being done. That's in red. And last thing is I need that plus 3. The plus 3 is a vertical shift up 3. So every single one of those points I'm going to go up 3. Start with my vertex, up 1, 2, 3. the other point, 1, 2, 3, another point, 1, 2, 3, and I'm going to do the left side of my function, and I'm just going to continue that pattern. I know it looks really weird with all those dots, but then when I connect these, we have my final graph here. There's the left side. Let's go ahead and do the right side here. And then if it helps, I'm going to go back with my eraser and erase all of these in between points that I was using for reference. And then I'm just going to clean this up since I accidentally drew over something that I didn't want to draw over. All right. So the green graph is the new one that I need. Now, the big takeaway here is you have to go in order of operations. Work from the inside of your absolute value symbol, then focus on the A value, then the K, okay? So that you do the H, the H value first, then the A value, then the K. Last thing you do is always move up or down. If you don't do it in that order, you will get the incorrect graph. Or just to double check, you could always put in your graphing calculator and make sure your graph matches what you have. All right, go ahead and do the last on your own and then come on back and then I will talk you through this one as well. Okay, so 3, 2, 1, go. All right, as you can see, I don't have anything written on mine because I want to go over this with you. The first thing that you need to be made aware of here is we have to focus on the +2 in there. So that the x plus 2 that we see in the absolute value, this is going to be a horizontal shift. So the opposite of plus is a minus, so left 2. So I'm going to make everything go left 2. Let's start with the vertex, and then everything else goes left 2. So I'm just going to put some green points here. So that's my first transformation. Then I look at the A value. First of all, the negative. You can do the negative first or you can do the 2 first. The negative, I'm going to change colors here. The negative means a reflection over the x-axis. So my reflection, as we saw earlier, is I'm going to stay where I'm at, and then I'm going to just put everything, the exact amount of spaces on the other side of the x-axis. I'm going to do just a couple points of each. Okay, so there is my reflection. And maybe to help my eyes here in a second, I'm just going to already start erasing some of these green dots just so I don't get confused, and maybe even turn in, get rid of that green one right there as well. Okay, so that blue one's where I'm at now. Now, it's the 2. That 2 is a vertical stretch of 2. Vertical stretch. This means you want to multiply each y value. So 2 means double. So if I look at my y value of this first point here, the vertex, that's a 0. So if I double that, I get 0. So it's going to stay 0. 1 below. So if I'm at -1 right here, double that would be -2. Let's look at the next point. I'm at -2. I double that, I get to -4. And now I can think of that line of symmetry right here. Let's just go and do the symmetric points. So if I look at this first point after my vertex I graphed, I'm 1 spot to the right. Let's go 1 spot to the left. The next one, I am 2 spaces away on the right-hand side. So if I'm 2 spaces away on the right-hand side, I'm going to go 2 spaces away on the left-hand side. You'll also notice that, think about this A value being in front of my X right now. Think of the a value being in front of my x. It's sort of like a slope, okay? A 2x. Negative 2 meaning the right side is going to be a negative slope, but the 2, look, I'm going down 2 over 1. Down 2 over 1. That 2 is also my slope. So now I have a new graph here, the yellow one. I'm going to keep going down 2 and over 1. I'm going to continue that slope that I just learned about, I just figured out. And now I'm going to go back and probably erase this blue. So now I'm at the yellow is my new graph. And the last thing is that minus 1. We always think about the k value at the very end. So that minus 1 is a vertical shift down one. Every one of these yellow points is going to go down 1. So down 1, down 1, down 1, down 1, down 1, down 1, down 1. And now what I can do is take my handy dandy ruler and just graph the red here, my final absolute value function there. So this is one of the crazier ones you'll get to. Put arrows on the end. And if I need to clean it up so I can see a little better, I'm going to erase those yellow ones. Boom. So that is my final graph of the function g of x. Voila. If you have any questions, feel free to reach out and ask me. If not, you're good to go. I will see you here next time. Good luck.